Quick thing before we start. We are technically the technology this show is about.
Yeah, that is a bit of a situation.
So Dastan did the research, wrote everything, made every call. But then, well, he outsourced the voices.
Which is honestly on brand.
Machine voices, human mind.
Across the show, these networks have served answers, verified work, paid strangers, and run agents with no company in charge. Yet someone still decides what model runs and how the money is spent. If there is no boss, who decides? This is plain Strata, where we take decentralized AI apart one layer at a time. Who decides? This is basics 8 of 8. And today it is about who governs the network with no boss.
Because, you cannot just put software out into the wild, walk away, and expect it to magically organize human behavior without some kind of rule book. I mean, the central tension here, the real spine of this entire conversation, is the friction between how a decentralized network governs itself and how it actually owns its models.
Right. And that tension is exactly what we will keep coming back to today. Open governance is slow but hard to capture, while centralized control is fast but, well, self-defeating.
Let me make sure I'm grounding that tension correctly before we climb any further. Centralized control is fast because one chief executive can just make a decision in an afternoon.
They just send an email, and is that done?
Yeah, exactly. But it is self-defeating because if you rely on that one executive, you just built a traditional company again, which entirely defeats the purpose of trying to build a decentralized network in the first place.
You sacrifice the very property you set out to build, right? So if we want to understand how these networks avoid that trap, we have to start at the literal foundation. We have to talk about who actually owns the model weights.
Okay, wait, let us pause right there for the listener who is new to this specific layer. When we say model weights, we are talking about the actual physical asset, right? The massive files full of numbers that are the result of all that expensive computing power.
Yes. Picture gigabytes or even terabytes of numbers arranged in massive matrices. Those numbers are the physical brain of the artificial intelligence.
They dictate how it speaks, how it reasons, how it creates images.
Right. And in the traditional world, a company spends $50 million on electricity and computer chips to generate those numbers. Then they lock those numbers on a private server. The company owns them, full stop.
So the legal entity of the corporation holds the keys to the server. If you want to use the model, you pay them a fee, and they let you access it through their interface. But in our decentralized world, who holds the keys? I mean, is it a binary, boss or no boss?
It is not a binary at all, actually. It is a spectrum. And we need to look at the physical reality of that ownership. On one end of the spectrum, you might have a single open project.
Like an open source team.
Exactly. This is a tight team of developers who built the model.
Yeah.
They operate in public. They share their code on platforms for anyone to see. But ultimately, those few founders hold the administrative keys to the repository.
That still sounds like a boss, just a friendly one who works in public. I mean, they could decide to take the repository offline tomorrow or change the license, and you could not stop them.
Which is why we move further down the spectrum. Next, you have a decentralized autonomous organization, or a DAO. All right, this is a collective joint holding. In this scenario, the keys to the model, or the treasury that pays for its hosting and further training, well, they are controlled by a smart contract. No single human has the password.
So the asset is truly held by a piece of code that answers to a group.
Yes.
It is not sitting on a cloud server registered to a guy named Steve. It is sitting on a decentralized storage network, and the permissions to update it are locked inside cryptography.
And moving even further down that spectrum, you have a token-weighted community. In this model, holding a piece of the network's digital currency is itself a form of partial ownership. Your tokens give you a literal claim on the direction of that model.
Okay, that makes sense. Are there middle grounds here?
There are. Finally, you have hybrid models, which are very common right now. The founders hold the keys today, but they have a mathematically binding promise written directly into the code to hand that control off to the community over the next 2 years.
Let me see if I can map this to something familiar. It is like moving from a sole proprietorship, where one person owns a bakery and decides exactly what time it opens, to a public co-op.
I like
Yeah, in the co-op, every person who shops there owns a fraction of the building and gets to vote on what bread is baked and who manages the ovens.
That captures the transition perfectly. And if we tie this back to the spine of our conversation, where a project sits on this spectrum reveals if it is actually decentralized. beneath all the marketing copy.
Right, because if a network claims to be decentralized, but the founders can unilaterally delete the model weights tomorrow, they're just a sole proprietorship wearing a co-op name tag.
The physical reality of the keys matters more than the press release. If there is a backdoor for the founders, there is a boss.
Which brings us to the next obvious question. If the co-op owns the bakery, how do they decide which flour to buy?
Exactly. Once you understand who owns the asset, you have to figure out how they maintain standards without a boss to just point and dictate. This introduces our next primitive tool, the token-curated registry.
I hear this phrase constantly, but it always sounds a bit abstract. It sounds like financial jargon mixed with art history, honestly.
Well, let us break down the words first to ground it. Curate comes from the Latin curare, to care for.
To care for.
Right. A curator in a museum is the person who physically cares for the collection, making sure the art is preserved and authentic. And registry comes from the Latin regere, to record. It is simply an authoritative record. So a token-curated registry is a cared-for record.
A cared-for record, I like that. It strips away the technical intimidation.
The anchor analogy here is Wikipedia's editing rules versus a traditional newspaper editor. A newspaper is fast but centralized.
Right, the editor-in-chief decides what goes on the front page, and it happens by the morning edition.
Wikipedia, on the other hand, is governed by a complex set of rules and a messy, massive crowd of contributors. It is much slower, there are endless arguments on the talk pages, but it is incredibly resistant to capture.
Because no single billionaire can just buy Wikipedia and force it to publish a lie without the crowd immediately reverting the edit.
Exactly. The newspaper is the centralized boss. Fast, efficient, but totally vulnerable to one person's bias or financial incentives. Wikipedia is open governance. Agonizingly slow, but extremely hard to capture.
Yeah, but Wikipedia relies on volunteers arguing out of the goodness of their hearts. How does a decentralized AI network do this? I mean, how does the crowd actually care for it without an editor? What is literally happening?
Let us drop all the way down to the mechanism for a moment. This is the ocean floor of how these networks filter information.
Okay, take me to the bottom.
Imagine we have a registry of safe, reliable AI models. You want to add your new model to this list because being on the list means users will trust it and pay to use it.
Makes sense. It is like getting a seal of approval.
Right. But to get on the list, you must stake a specific amount of money. Let's say 10,000 tokens alongside your submission.
Wait, I have to put down a physical financial deposit just to suggest an addition to the list?
Yes. Your tokens are locked in a smart contract. That stake is your financial claim that your model belongs on the cared-for record. Now, the rest of the token holders in the network evaluate your model.
And if they find a problem...
If someone disagrees, if they test your model and find out it gives terrible, biased answers, they challenge your submission.
And how do they challenge it?
They are completely forfeited. A portion goes to the person who challenged you as a reward for protecting the list, and the rest might be burned, meaning removed from circulation permanently or sent to a community treasury.
Let me see if I have this right. The list is maintained by the financial conviction of the crowd, not a person's judgment.
Yes, that is it.
You are literally betting your tokens that you are right. If I am the challenger, I am not just whining about your model. I am putting 10,000 tokens on the table, looking at the rest of the network and saying, I bet my own wealth that this model is dangerous.
You have it perfectly. The mechanism uses the threat of financial loss to force honesty. It is crypto-economic game theory in practice.
So if you try to spam the list with bad models, you will just go bankrupt.
And if you are a diligent challenger who successfully weeds out the garbage, you earn money. It replaces the human editor's salary with an open market of bounties and penalties.
But let me push back here. What stops a group of wealthy bad actors from just forming a cartel? Say I have a terrible model, but I coordinate with 5 extremely wealthy friends. I submit the bad model, and they just vote for me, overriding the honest challengers.
That is the risk of a Sybil attack, where someone uses multiple identities or massive wealth to overwhelm the system. But remember how the voting power is usually distributed? And returning to our spine, think about the trade-off here.
The slow versus fast trade-off.
Right. This mechanism is incredibly slow. A challenge period might last a week, and the voting might take another week. You cannot update this registry in real time. It requires deliberate friction.
Okay.
But it is incredibly hard for a single entity to capture because of the sheer cost. To force a bad model onto that list, your cartel of wealthy friends would have to buy enough tokens to outvote the entire honest network.
And if the honest network sees a cartel trying to force a dangerous model onto the list, they will all rally to vote against it. Because if the registry loses its reputation, the tokens they hold become worthless.
Right. The attackers would have to be willing to lose a massive fortune just to vandalize a list. The cost of capture is mathematically tied to the value of the network.
So if the registry is valuable, it is expensive to attack. If it is cheap to attack, it probably is not valuable enough for anyone to care.
Exactly. We are back on the surface now. That is a token-curated registry.
Okay, I see how that works for maintaining a list of items. It is a filter, but a filter is not a government.
What do you mean?
Well, what about bigger decisions? What if the network needs to rewrite its underlying code or spend $10 million from the treasury on a marketing campaign or decide which research team gets a massive grant? You cannot just run a yes or no challenge on something that complex.
You cannot. For that, we need a fuller tool, the Decentralized Autonomous Organization, the DAO we mentioned earlier.
Yeah, I hear the acronym DAO applied to everything from massive infrastructure projects to like a group of friends buying a rare comic book.
Let us define it immediately, so we do not lose anyone. A DAO is a token-weighted governance body that votes on real decisions, like protocol upgrades or treasury spending.
So if the token-curated registry is the immune system keeping the bad stuff out, the DAO is the brain deciding where the entire body should go next.
That is a great way to look at it.
So how does it work in practice? If there is no chief executive calling a board meeting in a glass conference room, how does a decentralized autonomous organization decide to spend $10 million?
It starts with a proposal. Any token holder, assuming they meet a minimum threshold of tokens to prevent spam, can draft a proposal.
And this is not just a forum post, right?
No, this is not just a forum post saying we should do this thing. Often, it includes the actual executable code required to make the change. They submit this proposal to the network.
Okay.
Then there's a formal period of debate on the forums, and finally, a cryptographic vote. Your voting power is scaled by how many tokens you hold.
So if I hold 1% of the total token supply, my vote counts for 1% of the outcome. Wait, I have a huge problem with this. That is a literal plutocracy.
It is.
If my voting power is strictly tied to my wealth, then a billionaire's vote counts 1,000,000 times more than a student's vote. It is just shareholder voting run on a blockchain instead of through a corporate proxy server. How is that fair?
It is a plutocracy, and that is a perfectly valid criticism.
Yeah.
In many ways, it is exactly like corporate shareholder voting.
So why do we do it?
The rationale is that the people with the most financial risk should have the most say in the direction of the protocol. If the billionaire makes a terrible decision, they lose $1 billion in token value.
And the student only loses a few dollars.
Right. The system assumes that self-preservation will force the wealthy to vote for the long-term health of the network.
I do not buy that wealth automatically equals good judgment, honestly. But I see the harsh economic logic. If you have skin in the game, you get to drive the car.
It is the closest thing these networks have to a parliament. You have different factions forming. You have intense lobbying on social media.
And you probably have people delegating their votes, right?
Yes, you have delegate systems where smaller holders who do not have time to read complex technical proposals can loan their voting power to trusted experts. It is genuine self-rule.
Yeah, but parliaments are incredibly slow. You have proposals, weeks of debate, and notoriously low turnout. I mean, most people do not even vote in their local city elections, let alone log into a digital portal to read a 40-page technical document and vote on a software upgrade.
You are going to have massive voter apathy.
Exactly.
And that is completely valid, and it points right back to the tension we established at the start. Genuine self-rule brings the slow grind of getting a dispersed crowd to agree on anything.
It is exhausting just thinking about it.
You have to campaign, you have to educate the voters on why the upgrade is necessary, you have to beg people to participate to reach a quorum, and you have to wait for the voting window to close.
Yeah.
It trades away all the speed of a centralized tech company.
A company like OpenAI can just push a model update on a Tuesday afternoon because a small group of engineers decided it was ready. A DAO might take 3 weeks just to establish a quorum to decide if they even want to think about an update.
And during those 3 weeks, the centralized competitor has already moved on to the next problem. This is why governance is the absolute hardest part of this entire field.
Because the AI is the easy part.
Right. The artificial intelligence is just math. It is just matrices multiplying. But a DAO is human politics encoded into software.
So we have the spectrum of ownership for the physical assets. We have the token-curated registry for maintaining lists and filtering out the garbage. And we have the DAO for making the big parliamentary decisions and spending the treasury. Is that the whole toolbox?
Not quite. There is a fourth primitive. It is a subtler arrangement, but maybe the most elegant one we will discuss today. It is the concept of economic ownership without control.
Economic ownership without control. Ground this for me physically. What are we looking at?
We see this heavily in the design of subnetwork owners. Let us use the Bitensor design as our concrete example.
Okay, let us look at Bitensor.
In that network, the entire system is divided into different subnetworks, each handling a specific narrow task. One subnetwork might be dedicated entirely to generating text.
And another might be for storing data.
Or predicting financial markets. The person or team who creates and runs that specific subnetwork gets a fixed cut of the rewards generated by their corner of the ecosystem.
How much of a cut are we talking about?
Historically, that cut is roughly 18%.
Wait, so they're getting a guaranteed slice of the economic pie just for setting up and managing that specific task?
Yes, and this creates a massive financial incentive. They want their subnetwork to be the most heavily used, the most reliable, and the most valuable in the entire system, because 18% of a massive pie is life-changing wealth.
So they are driven to recruit the best developers, market their subnetwork, and ensure absolute maximum uptime. Let me make sure I follow the logic. They have a massive financial incentive to keep their corner healthy because their income depends entirely on it, but they do not make the overarching rules.
Exactly. That is the brilliance of the design. The broader protocol, which is governed by the DAO we just talked about, mathematically caps what that subnetwork owner can unilaterally change.
What can they not change?
The subnetwork owner cannot alter the emission schedule of the tokens. They cannot rewrite the consensus mechanism that verifies the work. They're given economic ownership, meaning a direct financial stake in the success of the product, without broad control authority.
You know, this is a very specific cross-domain pattern. I have seen this before. It is exactly like the franchise model in traditional business.
Tell me how you see the franchise model working here.
Well, the person who owns a local fast food franchise is desperate for that specific store to succeed. They put their own money on the line, they hire the staff, they clean the floors, they stay open late, they own the local economic outcome. Right. But they cannot unilaterally change the recipe of the signature burger. They cannot change the logo on the sign out front. The parent company constrains them to maintain the integrity of the whole brand.
That is a perfect structural comparison. In our decentralized case, the parent company is not a corporation sitting in an office building. It is the mathematically enforced protocol.
So the subnetwork owners are aligned by money to care deeply, but they are constrained by code from capturing the system.
Yes, because if they were given full control, human nature says they would simply rewrite the rules to give themselves 100% of the rewards instead of 18%.
Right. And if they were given zero economic incentive, they would never bother doing the hard work of running the subnetwork in the first place. I mean, nobody runs a server farm purely for charity.
The split between economic ownership and governance control is what makes the engine turn. It harnesses greed, but builds a fence around it.
That is genuinely elegant.
Now we need to bring all these primitive tools together. The token-curated registry, the DAO, the subnetwork structures. Every project in this space exists on a spectrum built from these tools. Which brings us right back to the spine, the trade-off between open, slow governance and fast, centralized control.
I am noticing a pattern here as we look at the landscape. It seems like a network cannot just start out as a massive, perfectly balanced parliament on day one. I mean, it seems impossible to launch a project by committee.
You are absolutely right. Early-stage networks almost always stay highly centralized.
The founders make the decisions.
They hold the keys to the smart contracts. They might use a multi-signature wallet where 3 out of 5 founders have to agree to move funds, but they are effectively the bosses.
Why, though? If the entire ideological goal is decentralization, why start with centralized bosses? Is it just hypocrisy?
Because an infant network needs sheer speed to survive. On day one, the code is incredibly buggy. The market fit is completely unproven. There are existential crises happening every single day.
I can imagine.
If a critical bug is found on day 2 that is draining user funds, you cannot wait 3 weeks for a token-curated registry to debate the patch. The project would die before the vote even reached a quorum.
So early on, the founders decide, and they trade ideological legitimacy for the speed required to survive.
Exactly.
Yeah, that makes practical sense. When the ship is sinking, you do not hold a democratic vote on how to patch the hull. You do not wait for a quorum of passengers. You just have the captain grab a bucket and start bailing water.
Exactly. But as the project matures and the code solidifies, the nature of the risk shifts entirely.
How so?
It is no longer about fixing critical bugs fast. It is about proving to the world that the network is resilient. It is about proving that it cannot be shut down by a single government subpoena or ruined by a rogue chief executive making a terrible decision.
So mature projects begin to drift toward open governance.
Yes, they slowly hand over the administrative keys to the DAO.
So it is like a homeowners association versus a landlord. The landlord decides alone and fast. If the roof leaks, the landlord calls a guy and fixes it that afternoon. But if the landlord decides to double your rent, you have no recourse.
And the association.
The association decides together, but it takes 3 months to approve the color of a fence.
That is a great way to view the frustration of it. And here's another analogy for the exact same tension, but focusing on the stakes. Think of a jury's verdict versus a judge's ruling.
Oh, I see where this is going. A judge can slam a gavel and issue a ruling in 5 seconds.
Oh, right. The judge is highly efficient, highly trained, and completely centralized. But a jury trial takes days, sometimes weeks.
You put 12 random citizens in a room. They argue, they misunderstand the evidence, they get confused, they ask for clarification.
They slowly, painfully build a consensus. It is agonizingly slow.
Yeah.
Which one you want depends entirely on how much you fear a single point of failure.
We use juries for the highest stakes, like taking away someone's freedom or their life, because we are terrified of a single corrupt, biased, or simply exhausted judge having that much unilateral power.
That completely crystallizes it for me. When the stakes are low, or we need extreme efficiency, we want the landlord or the judge. When the stakes are existential, we want the jury, no matter how much they argue and frustrate us.
And in decentralized AI, the core thesis is that artificial intelligence is too important an infrastructure to leave to a single judge.
Exactly. We are willing to endure the homeowners association. We are willing to sit through the messy jury trial because the alternative is a single corporation controlling the most powerful technology on Earth.
Because if a single corporation controls the model, they control what it is allowed to say, what biases it enforces, and who gets access to the future of computing. Okay, I am entirely on board with the philosophy. But as much as we praise the jury and the parliament in theory, these systems are not perfect. In fact, earlier you mentioned that human politics encoded into software is incredibly messy. Where does this actually break down in the real world?
It breaks down in ways that are deeply uncomfortable for the people building these systems. There are 3 major unanswered questions, 3 open vulnerabilities where these governance systems hit a brick wall.
Let us get into the uncomfortable stuff. What is the first one?
Question 1 is the fundamental conflict between code and vote.
Code and vote.
Imagine a DAO holds a massive, highly debated vote. The community overwhelmingly decides they want to increase the total supply of tokens by 10% to fund a massive new developer grant program. They believe this is essential for growth. The parliament has spoken. The vote passes with a 90% majority.
Sounds like a standard central bank move. Printing money to stimulate the economy?
Yes, but the underlying protocol math, the smart contract deployed on the blockchain from day one, has a hard-coded absolute cap on the token supply. The code mathematically forbids the creation of even one more token. What happens? Which wins? The democratic will of the people or the immutable physics of the software?
Wait, the humans reached social consensus, but the physical laws of their digital universe forbid it?
Exactly. In a corporate world, the chief executive just walks down to the engineering floor and tells the team to change the database. In a decentralized world, the code is immutable. It cannot be casually edited.
So what do?
If the vote demands an action, the math forbids, the system fractures. Often, this requires what is called a hard fork.
A hard fork? That sounds violent. What is literally happening during a hard fork?
The community literally copies the entire open source software repository. They go into the new copy, they change the hard-coded rule about the token supply, and they start a parallel universe.
You are kidding.
I am not. Now you have 2 networks running at the same time, the old one adhering to the original code, and the new one adhering to the new code. Everyone who held tokens on the old network now holds tokens on both.
That is chaotic. The community has to decide which universe they actually value.
It is incredibly messy. It divides the community. It destroys network value because users are confused. And there is no clean theoretical answer to whether the social layer, meaning the humans voting, or the technical layer, meaning the immutable code, is the ultimate authority.
It is a genuine constitutional crisis every time it happens.
It really is.
What is the second open question?
The second open vulnerability is the stark reality of governance attacks.
We touched on this earlier with the plutocracy issue. If voting power is just tokens, what stops someone incredibly wealthy from just buying all the tokens on the open market and forcing a vote entirely in their favor?
Nothing.
Nothing.
That is the honest, terrifying answer, and it is an open, uncomfortable vulnerability that many projects try to ignore. If a malicious actor, say a massive hedge fund, sees a decentralized AI network with community treasury worth $100 million, they do the math. Yep. If it only costs them $60 million to buy a controlling share of the voting tokens on the open market, they will do it. It is a highly profitable trade.
They buy the tokens, they draft a proposal to send the entire treasury to their own wallet, they vote yes with their massive stack of purchased tokens, and they drain the protocol.
Yes. It is a hostile takeover, executed entirely within the rules of the smart contract.
If it is just a math equation and the math says buy tokens to steal treasury, why does anyone trust these DAOs with real money?
Because historically, the cost of the attack is usually higher than the reward. Or because the act of buying that many tokens on the open market spikes the token price so rapidly that the attacker runs out of money before they can secure a majority.
Supply and demand. As they buy, the price goes up, making the next purchase more expensive.
Right. But as these networks get larger and massive, well-funded institutions or even nation-states get involved, the defense against a hostile financial takeover is largely untested at scale. We saw variations of this with the hostile takeover of the Steam network years ago, where massive token holdings were used to vote out honest validators. The vulnerability is very real.
A decentralized system relies on the assumption that the majority of wealth will act honestly for the long-term health of the network. But if one malicious entity has more money than the honest majority or simply desires destruction over profit, the system completely breaks.
Exactly. And the third question is less about malicious attacks and more about the strange reality of human psychology.
Yeah.
It is the problem of model deprecation.
Model deprecation, meaning turning off an old artificial intelligence, retiring it.
Yes. Suppose the network has been running a specific language model for 2 years. The community loves it. There's a specific tone, a specific personality. But mathematically, it has become technically obsolete. It is inefficient, it wastes massive amounts of compute power, and it is entirely outclassed by a newer, cheaper model. The rational engineering move is to retire the old model, to deprecate it.
A centralized boss would just shut it down by fiat. They announce an end-of-life date on their blog, and on that day, the servers turn off. Everyone complains on social media for 3 days, but they eventually adapt and move on.
Precisely. But a collective might not do that. A DAO is driven by human sentiment and sunk cost fallacies. Maybe a vocal minority of developers built their specific applications entirely around the strange quirks of that old model.
So they fight to keep it alive.
They lobby, they write emotional forum posts, they rally support, and they flat out refuse to vote to retire it.
So the community might just stubbornly keep paying for a dead asset.
Yes. The network bleeds money, paying node operators to burn electricity, hosting a model that belongs in a museum, simply because a decentralized crowd is incredibly bad at firing its darlings. Managing the graceful death of an asset is a highly specialized leadership skill, and broad democracies are notoriously bad at endings. They prefer the status quo.
Let us take all these pieces, the primitive tools and the inherent problems, and put them into one single connected scenario. I want to see this whole machine running at once.
Let us do it. This is to lock the ideas in. Picture a decentralized AI network facing a massive transition. A brand new, highly efficient model has just been developed by a research team.
The shiny new toy.
Right. The community must adopt it to stay competitive. They must retire the old one to save resources. And they need to spend a massive amount of treasury funds to incentivize the node operators to switch their hardware over to the new model.
Okay, the table is set. High stakes, multiple moving parts, money on the line. Where does it start?
It starts at the gatekeeper. The new model must earn its place on the token-curated registry. The research developers submit it, and they lock up their massive token stake to prove they believe in it. Immediately, skeptical token holders challenge it.
They lock up their own money, arguing the new model has hidden biases or that its benchmark scores are fabricated.
Exactly.
The stakers are backing and challenging, risking their own capital to vet the code. It is an adversarial vetting process.
Right. For 2 weeks, the network runs a gauntlet of testing to resolve the financial dispute. Users try to break the model. Eventually, the model proves resilient, the challengers lose their stake, and the model is officially placed on the registry. Step 1 is complete.
So now the model is approved as safe, but the network has not actually adopted it yet. It is just sitting on a shelf.
Correct. Now we move to the Parliament. A proposal is drafted for the DAO. It reads, "We'll adopt the new model, we will shut off all financial rewards for running the old model, and we will pay out 5 million tokens from the treasury to cover the transition costs for the node operators."
And here comes the messy human politics.
Exactly. The forums explode. The developers who love the old model are furious. They try to rally a veto, arguing the new model is sterile and lacks creativity. At the same time, the subnetwork owners get involved.
Right, the franchisees, the people with economic ownership without control, they have their 18% cut on the line. They're going to fight for whatever maximizes their profit.
Yes. The subnetwork owners lobby hard. Some realize the new model will make their specific tasks run much faster, increasing their daily profits, so they campaign fiercely for the upgrade.
And the others.
Others realize the transition will cause server downtime, hurting their immediate payout, so they campaign against it. They argue passionately on community calls. They try to sway the retail token holders to delegate votes to them, but they cannot simply force the outcome. Their control is mathematically capped.
So you have brutal financial battles on the registry, sentimental and ideological arguments in the forum, and fierce economic lobbying from the subnetwork owners protecting their margins.
And out of all that friction, all that shouting and staking, the voting window finally closes. The quorum is met by a thin margin. The proposal passes by 54%.
Wow. Let me summarize the result here. A decision emerges from this absolute chaos. It is highly legitimate because no single party made it, but it is incredibly slow and fragile.
Yes, it took a month of fighting. A centralized company would have done it on a Tuesday morning over coffee. But this decision has a profound legitimacy that a chief executive's memo never will. The community owns the outcome because they bled for it.
That is what a network with no boss actually looks like in practice.
It is loud, it is slow, but it is highly resilient.
It is exhausting just thinking about it. You really have to believe in the mission to put up with that kind of governance.
Which brings us to the final, most provocative thought of this entire exploration. The true test of everything we have talked about today is not technical at all.
It is not about the cryptography or the slashing mechanisms or the voting thresholds.
No. The final open question, the one that determines if any of this actually matters, is whether these projects can hold their decentralization through their first major governance crisis.
What do you mean by a crisis? Give me a scenario.
I mean a devastating smart contract hack that drains half the funds from a subnetwork. I mean a powerful regulatory agency issuing subpoenas to the largest token holders and demanding they shut the network down.
Oh, wow.
I mean a fiercely contested vote where an attacking whale tries to buy out the treasury and destroy the protocol. When a network is flying high and the token price is up, decentralization is incredibly easy. It is a fun parlor game for developers.
But when things go wrong.
When the treasury is bleeding out, when the token price collapses by 80% in a day, and the network is 20 minutes away from total failure, the panic sets in.
Yeah, I see it. In a crisis, the temptation to just let the founders fix it quickly will be enormous. The community will flood the forums and actively beg the core developers to use their admin keys, to freeze the blockchain, to act like a boss and save their money. They will demand centralization to stop the bleeding.
And if the founders cave to that pressure, if they freeze the chain or rewrite the rules by fiat to save the funds, they prove they were only decentralized in the easy times. They proved they were just a sole proprietorship playing dress up as a co-op all along.
Right.
The true test is watching a network take a massive financial hit or suffer a terrible technical setback and still refuse to bypass the DAO.
The absolute adherence to the rules, even when it hurts, even when it costs people money.
Exactly. If you keep one thing from this exploration, if you're listening and wondering why you should care how a bunch of coders vote on a blockchain, it is this. The next version of artificial intelligence that dictates what information you see might be governed this exact way.
The stakes are incredibly high.
And the hard part of decentralized AI was never the AI. The artificial intelligence is just math. The hard part was building trust and decision-making among strangers with no one in charge.
The technology is just math. The governance is human nature with all its flaws and greed laid out for everyone to see.
The how is the rest of the show, no background needed. This is plain Strata, decentralized AI layer by layer.